Welcome to my YouTube channel. This is Dramani Online Mathematics. This is where you get all your detailed explanation. We are going to look at integration. We are starting with the definition of integration. But before we start, a lot of people, a lot of books, when you refer, they always say that integration is the reverse of what? Differentiation. And that is not wrong. That is right. Is that okay? Why are you saying that integration is a reverse of differentiation? Because if I have y equals 2x, okay, if I differentiate this dy dx, I'll get what? 2. Is that okay? Also, if I integrate 2x, I mean 2, so that is y equals integral of 2, we get 2x. So the reason why we are saying this is a reverse of each other is that when you integrate, the answer that you get, or when you differentiate, the answer that you get is the same as, or is a reverse of when you integrate. So that is the meaning of integration. But it goes further. Is that okay? Do you know that anytime you find area under the curve, it's also integration? Yes. Like if I have, let's say y equals, okay, x squared. Now let's draw the curve of this. So I have my y, I have my x, okay? So the x squared, if you are drawing the curve, it'll be like this. Okay? So now let's say that I'm interested in the area here. Is that okay? So from this side, let's name here A and here B. If I find the area under this curve, then it's the same as integrating this and substitute the values here into this when I integrate. So the area under the curve, when you find this, is what? Also integration. So integration simply means finding area under what? Curves. And we say that integration is the reverse of what? Differentiation. So these are the two definitions you should know. But the main understanding is that integration is finding area under the curves, just like the differentiation is what? Gradient at what? A point. Thank you very much. Now let's look at some examples. So now let's look at this. If I have y equals x squared, okay, good. If I also have y equals x squared plus 2, now I have y equals x squared minus 2. Now I want, okay, let me make this one minus 5. Let's see. We want to differentiate each of these, okay? So if I differentiate this, this will give me the y, the x to be equal to 2x, okay? Then if I differentiate this, I have the y, the x equals 2x. Remember, if you differentiate a constant, that will always give you what? 0. Okay. And have you even thought of why is it like that? I explained it to you in a previous video when we were doing the differentiation. And geometrically too, I can explain it to you. In fact, gradient of a horizontal line is always 0. If you draw a line of y equals 2, it's a horizontal line. So anytime it's a gradient, it's a constant, each gradient is 0. That's why its differentiation is also 0. So my dy dx is equals to, this one also give us what? 2x. This will be 0. Now, what is happening here? You realize that this function is not the same as this, it's not the same as that. But when we differentiated all these three, we are all getting 2x, 2x, 2x. What is happening to the constant? The constants are moving towards 0. Is that right? Good. Now, if we transform this one into integration, just like I said that for the integration, if I differentiate this and I get this, if I integrate this, I need to get back this. Is that okay? If I integrate this, so if I differentiate this and I get 2x, if I integrate 2x, I need to get back x squared plus 2. But if we integrate this, we are going to have the x squared, but the plus 2 will not be there. Is that okay? If you also integrate this, you are going to have x squared minus 5, but the plus 2 will not be there. For that matter, we decide, or the mathematicians decide, to introduce a constant called arbitrary constants. For that one, to cater for those constants that we don't know. So we will introduce C to replace that. So let's see something here. What you are saying is that if I have the integral of, let's say, dy dx of dx, if I integrate this, I'll get y. Okay, remember, if I differentiate y is dy dx, so if I integrate dy dx, I get y. Is that okay? Now plus, so anytime we integrate it like this, we add the constant to it. So the c here is what we call constant, the arbitrary what? Constant. Is that okay? Now why do we add the c? We added the c because there's some uncertainty there. We don't know whether there's a constant or not. Just like what I explained here, there were some constant, but when we differentiated, the constant abolished. So the same thing happened when you are integrating. Since we don't know whether there's a constant or not constant, we bring what? The c to replace or represent the constant that might be there. Is that okay? So anytime you integrate, you bring what? A constant. But here is the question. Is there any time if I integrate that I bring the constant? That's what I just said. But that's not always true. We have in some situation where you don't need to bring the constant. And when do we do that? And we have a situation where you need to bring the constant. When do we do that? And that one introduces us to what we call the types of integration. So we have types of integration. So one is definite, and the other one is indefinite. So these are the two types that we are going to look at: the definite integration and then indefinite integration. When we say something is definite, that means you know the end point. Okay, you know the end point. You know that when you start from 1, you go and end at 5. When you start from 3, you go and end at 4. But for the indefinite, you might not know the starting point nor the ending point. So that's the difference between the definite and the indefinite. So the ones that you think you might not know the starting point or the end point is where we introduce the constant. But the definite, we don't introduce any constant. Is that okay? We don't introduce any constant. Now let's look at something here. If I have y equals x squared, is that right? We want to integrate this. I mean, let me replace this one by n, where the n is any integer. Okay, we want to integrate this, the y equals x to the power n. So if you want to integrate, that means you bring the integral sign. Now you see that I'm writing some dx here. This dx is called operator. That dx is called operator. This operator works with whatever variable that is here. So if the variable here is, let's say, z, then here becomes the z. The variable here is v, then here becomes the v. So the operator works with the variable here. In any case, if here is x and here is the v, then you will treat whatever that is here as what? Constant. Is that okay? Good. Now let's look at the general way of integrating a function. So this is my function x to the power n. So if I'm integrating this, is what happened. We say that you repeat the same function, you add 1 to the power of the function, and the answer we had here is n plus 1 as the power. So we divide it by n plus 1. Because it's indefinite, we add what? C to it. How would you know that it's indefinite? It's when there's no numbers here, no limiting values here. Is that okay? So this is how we do what? We integrate. But let's say if I have y equals the integral of a x to the power n dx. Okay, just like I said, The operator here is the x, but here is what? Ax. So means that the x is working with the x, but this a becomes what? Constant. Is that okay? Anytime you are differentiating, there's a constant. There's a beautiful thing to do. That beautiful thing is bring out the constant, then you integrate. Is that okay? So means that my y will be equals to a x to the power n plus 1 divided by n plus 1 plus c. This is beautiful. This is beautiful. So this is how we do the integration. Thank you very much for watching. Make sure that you subscribe and share. In fact, we are moving on to indefinite integral. Indefinite integral. We are going to solve example and also stream into it to see what is inside that C. Thank you very much for watching.